Before we start the topical discussion, Pranav, we have a short rapid fire round for you. Are you ready?
Sure.
If you could unlock the genetic story of any historical figure, who would it be?
There's only one, Genghis Khan.
Okay.
One genetic superpower wish you had. Ability to build muscle, unlimited, like a Hulk.
Yeah, let's do a +1 on that. Awesome. If your microbiome could talk, would it praise you for your diet or file a complaint?
Now, yes. Earlier, it would have filed multiple complaints.
Okay.
And what's scarier? Running out of storage space for genomic data or running out of coffee during a crunch? I think genomic data. Running out of genomic space for storage space for genomic data.
You're not a coffee guy and you very sure.
Chai is my poison.
Yeah. And if you weren't building the GeneBox, what would you be doing right now?
Either playing a sport professionally or be holed up in a family business or running some management gig somewhere. Yeah, that's it.
Super, awesome. Thank you for being a sport and participating in the rapid fire. We get into the question right away, sir.
Yeah, that was wonderful rapid fire. And Pranav, now I think we should move to more detailed discussion.
So in one of your keynotes, you hinted your personal family tree going back, 2,600 years. How has your personal curiosity about your own ancestry influenced your work in genetics and genomics?
So, today there's so much data around, we're talking about AI these days, and there's so much data around that we now have a consumer segmentation on the kind of people who do their ancestry first, right? In the audience numbers, say out of every 100 people who do a genetic test, 20-25% of them do it for ancestry. It's the wanderlust. And we all wonder where we come from.
Yeah.
Right. And then behold, somebody in the family who's a historian comes with a family tree showing that you're the 135th generation in the family. On an average, you take 20 years between generations, you're still talking 2,500 years.
Yep.
2,700 years roughly, but yeah. So that's kind of where it kind of stems from. But now with GeneBox, obviously, I've done my DNA test with arrays, exomes, full genomes, etc. So I have a very clear idea, I think, where my family traveled from or generationally where we've traveled from. And I think probably a millennia ago, somewhere in Persia, and then slowly over the period of time, we've traveled that route and come and settled in parts of Western India. And then I think my grandfather moved to Bombay in early 1920s, but yeah.
Do you double click on that a bit? What is actually the process of, let's say, looking at what sample do people take to get your DNA first, and how do you trace that back in time?
Great. So, sample-wise, you need a biological sample. So usually saliva and blood are pretty standard right now. It's pretty robust. So you either take a saliva sample or a blood sample. We take that, we send it to a lab, we extract the DNA, we sequence it. Once you sequence it, the output is gibberish.
Right.
So if you see code, the output is usually 1 and 0s. In genomics, it's AGCP. So it's just AGCP randomly occurring over 3 billion base pairs.
Right. And how long does it take to sequence one person's thing, and how much does it cost?
So economies of scales have come down. There are multiple options now. So there is a smaller consumer-related chip that you can buy today, which is slightly cheaper, and the end user price is around 10,000 to 40,000 depending on where you buy it, etc. How much data you're getting, how many reports you're getting from there. Then you have exomes, which are slightly more expensive, which is more for clinical textile. And then we have whole genomes that are like sequencing a whole DNA. The consumer part testing is pretty standard, so the turnaround time is around 4 weeks right now. And once you have that data, like people like us have that data, then what we are searching for is, you've heard this, that you've inherited half your DNA from your mother, half from your father. That's correct, right? We try that half through generations. So basically, your own maternal grandparents' DNA is, 25% each in you.
Yep.
And the paternal is 25% each. And then you go further up. And then there are areas in your genome that are conserved, that don't that don't go into changes, and they're just passed on as it is. And it has a lot of benefits. It has also a lot of nuances and problems and diseases that it has. And that conserved area is what we track, and then we estimate against a greater population and realize where you've come from.
Awesome, fascinating.
So a lot of this is your data and compute aspect as your right. So that's where your costs and your time. So can you just explain for the benefit of also audience how some of this works in real world? So in genomics per se, the whole game was technology first was sequencing. The first human genome sequence project happened at charts. It costed around $100 million or something to get one genome sequence. Today, the cost of doing that at scale, if you're doing like a population program with the Singapore government or etc., that's all. I don't think they're paying more than $200 for a whole genome, right? But that is just the sequencing part.
Yeah.
Now, imagine the raw data for individuals around 200 GB at times. We have to comb through all of that. So it is a hardcore computation problem.
Yeah.
It is genomics now is just computation and science. It's a marriage of two, right? So its publication and data points is what you're looking at essentially. So from a layman perspective, imagine you're in a library and trying to find the right book for yourself. It's that way, without any help.
So often genomics can sound scary or over-deterministic to people. Now, like you mentioned, now with the AI, you're able to interpret the genomic data, predict the health risk. How do you balance communicating the benefits out of this whole AI-driven insights and the risk and uncertainties to lay users, medical practitioners, and non-science stakeholders? Because there's still a lot of myth, there are a lot of things that people really don't know about. Yes, correct.
So it's a great question. I think the biggest lacuna right now we all face is the lack of great or good quality genetic counselor. And counseling is a lot more about empathizing and speaking to people on an individual level versus finding the reporting part. So what we've tried to do is we've added some educational courses on a small initiative we called as the GeneBox Academy. And for the lay consumers who are trying to be fitter or have a better diet, or for the consumer who's on a medication today and his doctor needs to prescribe him a pill, what we've done is we've brought some CME kind of courses to it so that they can study through it and understand the counseling aspects. And obviously now with the advent of AI and the amount of information at our disposal, what we've started doing now for our practitioners and for other people is we're giving them counseling sheets. So wherein what happens is when we give them a counseling sheet, they essentially know what they're talking about, because a DNA report can go into like 1,000 pages. Now, if I ask you to go through 1,000 pages of a report and give me a summary, you're going to take a lot of time, and it's just not worth the effort because there's no kind of money involved in conveying that information. And that's where AI has been pretty useful in confusion to narrow down and say that, hey, no longer need to read the encyclopedia. You're looking for this project, why don't you read just these 5 pages and you're done? So that's what excited me when first time we met, and as a layman I just resonated that if I can know what medicine or what food works on me, that probably or what I should be doing to look after my health.
Yeah, I think for the longest time we've been speaking about personalized health and personalized medicine. This was a key literally.
So there is some fascinating work that results that we are seeing right now in how personalization of diet and exercise is working. Right? I mean, it's amazing. We have some good experiments with the GeneBox as well. I have really bad genetics when it comes to weight gain. I used to be 40 kgs heavier than I'm now. I used to be at least 46. So, and I could smell food and I would gain weight, right? But that's when I said my gut would have complained. That's when it would have complained from. But it's fascinating, right? Now imagine I have my blood test. I have my in-body scan, which I go to a gym and get a scan done and understand what my fat percentage. And I have my DNA report. And I have my gut microbiome report. Now this information is brilliant for somebody like me to give you an output. Because then what I do is I can define a food universe for you.
Yeah.
I can give you a list of food items you can eat, you can avoid, and you can moderate out, or you limit it.
Yeah.
right? Now imagine each of these layers provide a different narrative for the food that your body cannot absorb. Now, if I see that there's enough activity that you're going through, you're working out, etc., then the kind of diet risk that I can take with you is a little higher. But if I see that your lifestyle is predominantly sedentary, then I have to be in the defensive position and give it force that's not going to really harm your body the most.
Yep.
And these are inputs now today are totally enabling personalization, right? I mean, we've seen some fascinating results for people. So normally you would have said that chai, I said I love chai, but I can't tolerate lactose. So if I'm outside, it's half a cup of chai for me. At home, I get lactose-free milk from Amul, or if I'm maybe at one of the fancy Starbucks or something, you get a coconut milk, oat milk, whatever works with chai at times. So you pick that up, right? But there are those who would have a chai at least. If I don't have the milk alternative, there is no chai for me.
Or like a lot of people are gluten intolerant. So getting to know some of these early on
probably helps. I think my fundamental view is genetic testing should be done at birth, so that no child should go through bouts of unhealthiness, excess weight gain as child with pediatric obesity you see nowadays. You're seeing kids as less than 10 years old getting diabetes, after that. And it's a simple genetic test. It's a simple gut test. Do it, understand, and make sure. I mean, there are people who come and tell me, "Oh, हम तो गेहूं खा के बड़े हुए, कुछ नहीं हुआ हमें life में." I was like, go get the seed, genetically tested, see how much it has.
just probably not hybrid back then.
So, have you seen this farmer called 𝗵𝗵𝗶𝗶𝗃 or something of that sort? Yeah, 𝗵𝗵𝗃𝗃. And there's another ancient heirloom grain called as einkorn wheat. This they do it in Europe. The gluten in that used to be less than 3%. Today it's around 12 to 13%. Now, gluten is a proteins, right? So from 3% to 12%, so that's a 400% increase. Now, when you say 3 to 12%, people say it's not a lot of choice. But when you put it as a 400% increase, people realize. So, simple idea is, one roti you're eating today. Back in the day, you were eating one roti. Today, that's equal to 4. Your 4 rotis of the past today is equal to 1 roti.
Right.
So you can imagine the amount of gluten you're putting in. It's a protein. Now your body has a limited capacity to digest it. So imagine you take gluten now and you add a 400% increase, right? So then your body's capacity to metabolize is limited. So I may not be allergic, but the sheer amount of gluten you're giving me, my body cannot digest it. What happens that sits in your gut? It ferments. Then it produces metabolites that block absorption within your gut. Once your gut absorption is weak, you're not going to get the nutrients, the micronutrients, the microminerals, trace elements are getting absorbed into your gut state. Automatically, it's going to lead to outcomes that are weight gain, skin rashes, low energy, because you're not getting absorption. Now, this is a scientific way of putting it, but simple solution was, somebody in my family was very against what I was trying to say. I had a family and I was telling his children that gluten intolerant, they should not be eating gluten. So he didn't listen. So I said, okay, now this is the amount of food you're feeding your people. I went there and I made it 400 times. And I said 4 kapli roti is equal to 1 roti here. So you're giving your kid normal gehu 3 rotis. Let's do chapati set. Ask them to finish it and see if they have the same symptoms. Right, just from a gluten standpoint. So these are things that people don't really understand, that the food we eat also has changed. There's some good out, doctors, functional medicine guys, nutritionists out there saying, eat as your ancestors ate. So I was saying, go find those grains and then you eat. I don't have a problem. But till the time you're out, and today everybody eats out, everybody wants. So I feel if I can give you a list of 5 foods that you can eat once a month as an indulgence, which are your favorite, you're happy eating it at least once a month, right?
Yeah, that's
rather than not being able to eat it at all.
So if it was cheap day at least a month, right? So I just want to double click on what you said earlier. 20 to 25% of the customers that you have, people who are interested in this, look at it from an ancestry standpoint.
Correct.
And the others, I presume, are people who want to look at their DNA report for health and well-being. And microbiome test is also a category, right? Yes, and if you can just double click on the microbiome part, I think you refer to it as a second genome.
Yeah.
So where I read that it's 33 trillion human cells, but 39 trillion microbacterial cells in the body.
Maybe more than bacteria. Yeah. So the gut microbiome essentially is, the measure and study of the bacteria in your gut. Now, to put it in a very layman language, the gut bacteria are your workers. Okay, and they are there for specific purposes. Some will produce enzymes to digest your proteins. Some will produce vitamins. Some will produce other compounds in the body that are needed from time to time. So your stomach and your body does part of the digestion, and the part of it is the gut itself is the one that's helping out. So imagine there are colonies of soldiers, right? So if you are building a real estate project, imagine some of them are plumbers, some of them are electricians, some of them are your foremen, some of them are working at iron, etc. So your entire gut bacteria is like a second genome. And if you had a bad gut, you do. Because everything starts from there, right? Because your gut is the engine where all the absorption happens. All the good stuff gets extracted out and gets passed into your bloodstream. So imagine that is your weak part, then you have some massive issue there. So I think, and the gut is so dynamic. It is so dynamic that, to be honest, if you are somebody who suffers from gut health issues or serious gut issues, I would recommend to test it every 3 months till you are able to get the right probiotics / needed antibiotics to align your gut and get into good health. And that's a test that's repeatable, right? So, and that's the one that's your mile marker, because DNA you're born with.
Yep.
We can't change or alter your DNA. You ever heard that people change their DNA? That what they mean by that is the expression of certain genes. So, for example, if you don't sleep well, then part of certain genes switch off because your body's thinking you're in survival state, so it doesn't need, etc., to produce or activate these genes. Wherein the gut is very different, right? It's a food you feed it. If you feed it the whole nourished, great, less processed food, the gut's happy because it's got enough to do. But if it's not, and as I said about gluten, similarly with lactose, it converts into lactic acid if you can't produce lactase as an enzyme. And that causes, all the other food issues that you have with stomach issues. We all know what lactose does to you, right? So imagine your gut becomes a lot more lactic acid, how much the good bacteria can't survive, and then becomes a downward cascade. So that's why people are like, when some people who are lactose intolerant eat paneer, they have really bad morning. Yes, morning is because of diet, right?
Right. So just connecting it back to the question that Deepak was asking earlier. So this, you are phrasing it as a big data problem because it's dealing with your own genome and then the microbiome and stuff like that. So tell us about the magnitude of that. You spoke about 200 GB for one person. So imagine every child, your vision was every child has to do it. What does that look like, and how do you apply AI to this?
So, firstly, let's address the size of the data problem, right? Again, as I said, I'm a straight shooter, right? So, I personally feel it's going to be cheaper to do your DNA again than store it for life. Right? Because the cost of sequencing is coming down so much. So, having said that, you're not there yet, but the 200 GB is raw data essentially, right? So for us, the idea is to get down to those million variants, and we are really of concern. Out of the million, we're looking at a few thousand variants that are really the ones that are going to determine how you were different from me and I'm different from him, etc. Right? That angle is going to happen for that. But it does produce that amount of data in pre-processing at least, right? So you need architecture, infrastructure for that level. Now, even if I were to make the consumer side of things, and I'm going to take a 20 MB file, and if I was to print it out, it's 65,000 pages forward and backwards. And that's the amount of data. So imagine just going back, the biggest library you can go to, and you're trying to find a spelling mistake in a book, right? What AI can do is very quickly read all the books and then find out these 100 books or these 50 books for human look or human contact to kind of come and say that, hey, these are things that we think are suspect. I will look at that. So AI has become a brilliant enabler. Some of these reports used to take weeks.
Good.
Now we do it in seconds. right? So that is where the true power comes from, right? Is your ability to sort data, pattern recognize. Now if I give you a very specific task, is find a spelling mistake in a book. Imagine the number of hours you would have humanly spent to kind of read those books. That's where kind of it's a AI. Now the big data problem is because the file size is huge. Genome data production has spoken to be of exabytes per year now. If we get to the forecasted is to 2 exabytes a year, that is the genomic data production that will happen somewhere in 2030. Today, I think the whole of YouTube is then low to exabytes. So just to give you context on how big a data problem this is. So if I think, I may be wrong, but I think it's 100 million people get the genome sequence done in the next year, there won't be enough storage space for it.
Okay.
All right. Forget computation power. So it's a data and a compute.
Okay.
Awesome. And I think you also said that less than 2% of the genome is functionally relevant, right? And yet it holds close to 20,000 genes and over 4 million variants per individual. Okay. So in that context, how do you separate the signal from noise? So we already know there's a lot of noise, right? It's a needle in a haystack problem, right? The same thing that I explained with the book, right? If I'm trying to find a spelling mistake in a library.
Yeah.
So sometimes what we do is we end up working it the other way around. We're looking at, okay, we know this patient's a diabetic, and we know that these are some of the genes that are being studied enough to know that they are functionally relevant to diabetes. Now, is there a misspelling somewhere? Is there a variant sitting there that's going to maybe affect your insulin sensitivity? Okay, or is it affecting your absorption for carbohydrates, or is it affecting how vitamin D3 is absorbed in your body, right? So these are things that we kind of have to focus on to get the signal right. Otherwise, it's just noise, right? Because so you'll overlay the known data around current symptoms of treatment on top of what you get through the gut biome and DNA. Is that a very layman and a very over top bird's eye view? Yes, that's kind of where we kind of look at to find more information, right? But as I said, you can also look at the other way around, and we know that this particular variant is an issue. It's going to cause, say, say, pick up anything that you fancy. For example, your fat metabolism. Whether olive oil is good for you or not, right? So if olive oil is good for you or not, that's what I'm going to find. And I know that this is one variant that is responsible where olive oil becomes beneficial. Then I have a customer data of 1 million customers. That's where I'm trying to find the same variant and we can analyze it. So over a period of time, what happens is the more data we collect, the more data points we're able to identify. The more data points we're able to identify, we're able to increase the signal stronger. Noise from signal, and then also the challenge of what Rajiv was asking about the volume of data that we're dealing with. I think one of the essential challenges always would be for the kind of the DNA and the size and sample that we spoke about at scale would be the cost. And I think today everybody is looking at AI as the way, because a lot of things anyway we do a human, it's thought possible to solve. But there are models which has also the cost benefit. So how do you see this whole AI into this evolving at scale? So there are two things, right? One is you first use AI to figure out how efficient are your current algorithms or computation, right? To begin with, are you maximizing it to that limit, right? Is it efficient enough? Because you also have to understand that this is not an area or a problem that most people understand. It's a biomath problem, right? So not everybody is going to be hands-on with it. And that's kind of where we spend a lot of time to scale it up. We are no longer on-prem, we are only in cloud because we've got that scale, plus the kind of outputs that we cannot now manage on an on-prem server. Even if I take if I were to buy a 50 lakh rupee server today, it's already obsolete for me because it's going to have a finite amount of capacity, and computation the way it's been written till now is only going to address maybe 100 samples for me in 2 days. And that's not a quick enough turnaround these days. People want it in minutes. So We use a lot of instant-based computing right now. It is slightly more expensive for us. But I think the computation problem is getting solved through GPUs. We don't get the same results as yet, but we've, in terms of data quality output, I'm talking about, because the pipelines and algorithms are slightly different. But we're seeing some real promise. So, what our on-prem server that we ended up spending 25 lakh rupees on a few years ago was able to do, say, for example, 48 samples in 3 days or 4 days of computation. The RTX 5090 is doing it in less than 10 minutes, right? So it's crazy, from 48 hours to 10 minutes, right? The scale on GPUs is changing, but that can only keep you getting better, right? Hopefully. And that's kind of where our aim is. Now, you've seen all the LLMs and come out, the AGI part that have come out, and these are expensive. Well, these are inexpensive when you use it for a limited output. They're inexpensive when you're trying to solve one particular problem. But how we've discussed earlier that, hey, I have your all 10 different types of data fields, huge file sizes, have to compare the outcomes and give it to you, and maybe build an own LLM and work on top of that. These things become really expensive, right? So going forward, I think consumers also will need to understand that if they want hyper-personalized nutrition plans, diet plans, exercise plans, lifestyle plans, they'll end up paying a subscription fee or something of that sort to kind of keep access to that. Because I still feel the venture capitalist world is subsidizing AI, but there will be a time when it's where you got to spend for it. I personally feel that putting an LLM on a phone is not going to solve that problem, because just genomic data is so huge. So either you have to wait for the next advancement of a handle, or if you're still going to use the servers, and you eventually will have to end up spending a lot more on that. So your unit economics, willingness to pay, and then thereby the right to what level of accuracy or personalization you want to go and build it. All these are the levers that will evolve slowly as we go along. Yeah, but so give you an example, right? Today, if I give you all these data points, and you gentlemen are pretty smart, and you how to do it as well, you'll still take 2 to 3 days to do it, because there's just so much to constantly go through and double check and recheck and etc. That is where we help practitioners narrow it down to a 5-minute, 10-minute, 20-minute problem. That's kind of where I think the biggest applicability is going to come from. I think the end user customization, etc., is still some time away, but I think the biggest crunching game will be with practitioners. I think if you're able to crunch that time and give them a more focused and a more detail-oriented outcome that is important for their patient, I think that is a bigger game changer.
It's a nice segue into the question I was going to ask you. You have multiple stakeholders that you deal with, right? So it could be academicians for research, clinicians, stem cell scientists, and so on. Now, each stakeholder could have a different perspective on things. Where I'm coming from is, if you look at a disease, for example, back in the day, people said, oh, it's a gods that are doing it. Then you had a phase when microscope got invented in your hand, the germ theory. And now we are talking about genome. There are people already talking about epigenetics being more important than genetics and so on. So this is also an evolving field. Seems like the more advanced our technologies become, the better our insights become, and our worldview also changes with that. So with that kind of a moving target that you have, how have you been able to build trust with different stakeholders, given that this is sensitive data, correct, sitting on a platform and you're offering it on a subscription kind of a model? Can you take us through early days of how did you break this thing, correct, and get in, and how do you continue to build trust?
Correct. So I'll answer this in parts. I think the first question that you kind of pointed out was, it's an ever-evolving field now. There's epigenetics mentioned, and there's going to be multi-omic data, etc. All of that. So genetics is not a fad. It is something that is the most deterministic thing that we know. We know that you're born with certain DNA and never going to change it, right? So we have something called the central dogma of life, which is like DNA, RNA, protein. And every enzyme, every hormone, every receptor in your body is a protein. So your DNA is a blueprint to your body. Yeah. So think of DNA as a layer. Don't think of it as a product. It's the structure on which you build other applications. The word you mentioned, epigenetics essentially is trying to measure how efficiently is your DNA being expressed, or how efficiently is your body following the instructions. That is where epigenetics comes into picture. So it's a measure of how well your DNA is being expressed, and somehow one of the functions links back to longevity. So that's why people are, kind of talking about it. Longevity is very important, because now it is important. But if you treat your life right, how do you treat your life right? You go back to your DNA, right? So DNA is a layer. I wouldn't say that it's going to go away anytime soon. It is still a layer that's going to be needed. And what I explained to you was DNA, RNA, protein, and these proteins, these receptors, etc., are then eventually used towards drug discovery, right? So that loop's pretty evident in place. The next part was it difficult in the beginning, right, to build trust, etc. Doctors had used it, right? So DNA sequencing, people, now we do it at scale. Now I've sequenced a full DNA. Earlier, because I had limited budget and resources, I would just do 1 gene. I would still pay the same amount of money, but for 1 gene, right? So in fields like cancer, in fields like cardiology, like long QT syndromes, etc., it's pretty evident that genomics works. So those guys were much easier to convert to. Fields like psychiatry was the most difficult, in my opinion, today for the world also. Because if you historically go and see psychiatry, it's the demons, not the gods, right? From there, it went on to which disease of what all. Then it came down to what your mother did to you as a child before the age of 3.
Right. Your developmental psychology.
But at the end of the day, now we know it's genetics, right? I mean, this is a huge component of genetics, right? Because how your brain works, your synapses work, the genes that are responsible. We all know the dopamine release. We all know do scrolling on Instagram or YouTube just to give you the dopamine hits that make you happy, right? So those were the categories that were a lot difficult to kind of convert. Thirdly, I personally feel the problem I chose to solve, India was not the right place to solve it. In hindsight, it was the best place to solve it because it costed me a lot less money, right, compared to the US or somewhere else.
And the kind of richness of data you get in India.
Yes, so we're still exploring that, right? I mean, Indian diaspora, there's only 10,000 genomes the government sequence. It's still not yet open, so we have to kind of do a lot of our own legwork, etc.
Okay.
Plus, because we are so abundantly present in every country, right? 1 in 6 is an ending, right? So there are a lot of public databases where Indian genomes are available, where they're published. So we have some comparison grounds outside of India also. So the Indian Genome Project is around, they want to do around 4,650 odd unique populations identified in India itself. So 4,650 unique populations just in India. Well, put that into perspective, there are around 200 countries in the world. Right, so the diversity you get in India is humongous. You're right on that part. But so earlier days it was difficult. Even today, venture capital funding is something that Indian VCs, I'm sorry, but you guys just don't understand the industry as much, right? Because when you speak to, we've spoken to a few of them. Those are really smart guys, right? They started talking to us about algorithms, and they were understanding algorithms, right? But they were not able to understand business models. They were not able to understand why this is a niche. Now, I am thinking the same way when Tally was invented, when Tally was written, right? And everybody had a money in their office. They're like, Tally ko use nahi hai. Today, it is arguably one of the best success stories come out of India, right? And it's brilliant how they scale the business. I mean, I'm a fan of the product, right? And how they've done it, etc. So that is how archaic the thinking was when it comes to something like genomics. And when you go and speak to people here, they'll be like, are you vertically integrated? I was like, you can't be vertically integrated. That is essentially the whole theme of medical testing, that this should be independent. Because if you're totally vertically integrated, you're compromised. If my lab guy makes a mistake on a batch of 24 samples, it's going to cost company 1 lakh rupees to hide it, to redo it, etc. Right? Now, if it's independent and there are checks and balances in place, there's a company like mine that's going to say, hey, I'm going to read the data quality, and if it's not at this threshold, I'm going to reject the sample. That doesn't happen. And I don't want to name names, but I can show you some of the best labs that are funded, etc. produce data which is actually garbage and sell it because the consumer doesn't know any better. So in my opinion, I think it should be, that was the most difficult part that we faced. And now people see the value, so it's not easy. Like some of the reports I was reading about, the studies being done in US with Stanford Medical and few others, of how South Asian genes are susceptible to certain kind of, early onset of these. And I think a lot of data, like you said, is globally available because Indians are and Indian genes are available. But increasingly, this data is also getting used either by, say, a pharma company on early drug tests. So when you build something which has many use cases or probably people who will like to, so it's not just about my interest in knowing about myself, but over a large pool, I think how the data can help build either right kind of food brands in the market or right kind of medicines in the market. But when you think of all of this, I think there's also a question that increasingly comes about the whole privacy, security, ethical use of genetic data. So, and I think given that how personal and potentially sensitive this data is, and as it starts to becoming more richer, right? I think it can be used. I'm not very sure, but I heard about some even weaponizing this data to has been done, and like but some of you all would know is yes. No, I heard about some data about ● from, and it could also be used to build either next set of vaccines or antidotes. And so just curious to see, how do you see this whole privacy, sensitivity, ethical use of data? So I'll address the second part with how we see it and how I see it, but I just want to concur that what you said, a lot of it is right, because that's how the DNA, RNA, protein, the thing that we covered earlier, it works that way, right? There's something that, I've been trying to do for a while, but I don't think India is the right kind of market for it, is to come up with a private digital biobank. Okay, wherein what we can do is have the data on blockchain, not the entire data, but at least the transactions on blockchain, and initiate. Say a pharma company comes to me and say it wants to do a drug trial, or wants to target consumers with, say, Parkinson's disease. Right now, in my database, I already have, say, 1,000 people who want to for Parkinson's. And this all information is ready with the software or the system itself. Okay, the pharma company says that it needs 100 or 200 customers or 1,000 customers for something like this, where the software can easily just send you a notification saying that, hey, person A has a risk of Parkinson's and your risk is this high, and there's a pharma company willing to access your data. Would you mind paying for it, etc. Now, this is the only way you can fast track the development of new drugs, orphan disease drugs, at a very rapid scale. Now, if I was able to want to go and recruit them the way all the FDAs are telling me, my recruitment process is a 5-year process. Yeah. Right here, it's a 5-minute process. So there are ways that we can execute this, and this is something that I've been really this is like my pet project on GeneBox next is we've collected so much data. How do we help you generate more value out of it? Right? And the cost of you participating in just giving your DNA out. Now, this is not a drug trial wherein somebody's going to come and inject you with something. No, this is just to study your DNA to see if there's a target on it that could be useful, or that can be used to make it. But still, I think the consent part, like you said, can be solved. The ethical use of the data is still how the DASI is finally going to use it. So that's where I say that it should be a digitized private biobank, right? That's where the data should be. Now, data policies across are a very estimate, right? And what people don't understand is frameworks are good, right? They kind of help you. Law and order framework, all is all helpful to kind of help you understand that protect consumers, right? But you actually also have to see how the real world happens on the ground, the work happens on the ground, and you have to protect that, right? So for us, every customer who comes to us is a barcode because we are a B2B player. Only as a friend, if I get a DNA test done, I would know that this is Deepak's DNA. That too, I would know that. My team wouldn't know that because by the time it logs into the system, it's a barcode. So nobody has access to it. All of that is just not there. We have separate databases to store your DNA versus analyzing it. So all those pipelines are different, and we have already GDPR compliant. We already do business in Europe. But there is a regulation coming in Europe where even bioinformatics, algorithms, etc. will be classed as medical devices. So there are ISOs for that. We're getting those done right now. So
Deepak and I have been having conversations on the India AI story. So one thing that stands out, Deepak, when I listen to the story, right, is how on data, India seems to have something to offer the world, right? While compute, we may not have enough, or LLMs, we don't have anything significant at the moment. But use cases like this can be the solution for the world.
Correct. Yeah, and I think here the quality of data, unlike in many other use cases, is not an issue. In many other use cases, I find the labeling and the quality is an issue because here you are doing the sampling and you are bringing the data in. So absolutely, I think. And India could be the data capital in the world for many drug discoveries and early onset stage. But if you really ask me, India is a country of improvisation, right? I mean, we may not be the guy to come up with the first code to solve the big problem. But if somebody is done it, how can you improve that? I don't think there is a parallel for Indians to do that, right? So I think we're seeing all these LLMs in the West because A, you require that kind of capital. B, most of these LLM engineers, most of them are Indians in which ways, right? And when you are trying to do something revolutionary, you're only going to have 0.005% of the human intellect who's going to solve it, right? That's okay. I mean, we've only seen one Newton, one Aristotle, one Plato, one Michelangelo. We've not seen like millions of them, right? So the idea, what I feel is it's okay for a race to solve a problem that is intellectually very difficult, like putting a man on Mars, right? It's going to be maybe 1,000 people who will do it together, or 5,000 people who will do it together, out of population of 8 billion by the time we reach that, right? So, but once it's done, how do we repeat it? You saw Mars mission as well, right? The cost at which we did get it. So I think India is a country for improvisation. I think it's okay for the West or any other place to build something and prove it works, and then give it to India, and India will do it. So I think one of the themes that we have been touching through podcasts, both Rajiv and I, we discuss is there an India way? And I think what you just mentioned is pretty much where we are solving for population scale and also looking at the human side of it. I think that's an area Rajiv is very, very passionate about.
Yeah, totally good. So I think your last answer also, it was a nice segue for me, right, to talk about the kind of talent you need to run something like this, right? So given the mix of disciplines here and poor understanding in general, so we've all studied science, but we learned a lot today in the last 30 minutes. So you need folks from bioinformatics, genetics, engineering, product development, and maybe community people as well. So firstly, how do you attract this kind of talent? Second, how do you groom this talent for your vision?
So, I mean, I think the first thing we look at is, do you have that little crazy to solve a problem? Do you have that curiosity that is the fundamental output that I look at? But one thing that I look at is input, not output, but input I look at is, do you have the curiosity to solve a problem, right? If you have that and you have some basic intellect, you will solve this. See, agreed, it's a biomath problem. It's not easy to hire. We have to get people from ground up. Now, for the longest time, genetics was all about 1-2 genes, 1-2 data points. Most PhDs people do, they spend 5 years on trying to study one disease and 5 data points associated with that disease. So they really don't know how to write bias queries or they studied, and seen what actually happens. Okay. So then for us, they're essentially curators of information. That's it. And they've become very irrelevant. Now, if this course essentially had the skill to code, that person would become somebody that we would love to have on board. On the other hand, I can get somebody who can code, but if they don't have the love for biology, then no one will be able to solve this problem. So I think one is because I come from a genetics background, my first proper project in academia was on, my thesis was actually on using bioinformatics, right? And bio-IT was my thesis and it started from. So although I don't code that well, but I can still today understand how algorithms work, how frameworks work, etc. And then we've been able to get the right kind of people, and the vision has been there, to do this. So I think I'm pretty lucky as well with the kind of people we've got, and some really good ones have stuck around for the long journey. It's been difficult. COVID was really bad for all of us. So yeah, but we've also written some really cool stuff, built some good products. It's highly scalable. So we've got some really good outputs that way. But over a period of time, hiring talent is a problem because, as I said, we are trying to build the product. Once we get to the improvising stage, then the talent is easier. So we were pretty lucky to get our core straight up front. That was quite good. And there are very few jobs in the field that we are in, right? So really dedicated and passionate about the field, you will come knocking for sure.
And given that today a lot of Nobel Prize winners in the field of physics or chemistry are actually AI researchers. So are you looking at people who probably are technologists who have, like 𝗵𝗵𝗶𝗃 won the Nobel Prize for chemistry, I believe, not connected to the domain at all, but he used AI, had a beginner's mindset, and sort of got it done. So are you also looking at it from an outside-in perspective?
No, because it's human healthcare, right? So that unfortunately becomes a different kind of company, to be honest. So if I were to say that there's a spin-off coming out of GeneBox that's going to look at from the outside in, that's a possibility, yes. But fundamentally, GeneBox approaching this becomes slightly more difficult because our recommendation lead to directly what consumers do, right? They put food in their body or they take a drug, etc. So sometimes it's difficult. Having said that, the pure ability to do something new, independent, and that curiosity of taking AI and using it for chemistry done by a totally beginner's mindset is not the kind where I think most of us come from, right? I think most of us are like, this is done, how do we improve it, is what I've seen in our country also. So I also feel that this is more how things are done in the West. Like, even if tomorrow I had $1 billion and somebody came to me, my first thing is, 𝗵𝗿𝗄𝗏 we don't encourage that kind of research here in India as enterprises itself, right? Most of the companies who brought that in are from the West, right?
Yeah.
They used to. We've all heard about Google's offices, right? You're not going to get that office at Ambani or an Adani office, right? That's not how we are programmed to think.
And it's the other theme we are picking up in terms of India's focus on R&D, right?
But I think just building on what Rajiv said, I think one of our challenges has always been, like you said, I think I like two things. One is the trust in what you do. Yeah. And second is, if there is trust, how people are using this data to improve the quality of life. And obviously for a country like ours where access to healthcare is still a challenge, I think the preventive part of it creates a lot more value than once you are in there and then you go through. I think globally, if you have a little bit of money, India is the best place for healthcare right now. Compared to the West, I mean, you've seen what's happened to the NHS. You've seen what's happening in the US with insurance, right? I mean, $1,000 for an insulin injection is ridiculous. Absolutely. So I think that's where my next question was. So this whole idea of, the DNA passport in Europe as we speak. And if you look at it, how do you see that concept evolving in India or other emerging markets? I think that's a very important thing to see. I mean, obviously, we do not copy paste a model, but seeing in our context how something like that could emerge and be of value. So I think it can start with something really small. Okay. You can have an opt-in DNA passport for something which is a laser focused application, for example, something like mental health, wherein there is now enough awareness, there are not enough solutions, there are not enough counselors, etc. And it is something which is people don't like to advertise or openly talk about, right? So I think that is a brilliant area to kind of target and say that, hey, you have a mental health issue, you have the demands of the world, you have other institutes that are doing some phenomenal work in India. Okay, link it to maybe Ayushman Bharat or link it to other initiative schemes where you create an opt-in and help with mental health challenges. See how the model really works. Okay, so for example, you do a whole genome sequence there, you do the microbiome as well. You see any correlations there, you do the pharmacogenetics on it. So the patient who's today, broadly speaking, the way medications being given in this area is, these are lists of 10 drugs, and you start with the first one, then you go to the second, then you go to the third, go to fourth. Sometimes it could be 6, 7, 8 months before you find the right drug that works for you.
Right.
With pharmacogenetic tests, we will give you the probability of which drug is going to work the best for you in the order also. Alright, so we can directly probably hit drug number 1 or 2 or 3, between the 3, the top drug in the 1, 2 or 3. You don't have to go to 6, 7, iterations of it, etc. So that's kind of where I feel if we try to implement it, on a massive scale is going to fail. I think anywhere is going to fail on a massive scale. So it can be an opt-in program for mental health or something of that sort, or for women's health, for example, right? Women can't openly talk about women's health, right? If you go to see PCOS, PCOD, it's not something somebody will tell you, hey, I have a problem with this. It's a community thing. We talk. So I think anything where it is a taboo, or it's something that is morely community centric, I think that's something where we can look at this from my perspective, and because if it's a laser focused program, then that is something that can
take specific communities or the problems and then go deeper. So Pranav, as we were discussing about how's DNA testing helping people go look for personalized nutrition, diet plan, helping the kind of food they eat and what they eat. We spoke about 𝗵𝗲𝗃 to gluten, but in real life, how is this translating into behavior?
So a lot of people now, see, I think it's an age-related thing also, right? You talk to a 25-year-old, talk about nutrition, you're like, yeah, I want to eat my pizzas, I want to eat my chicken, I want to eat my processed food, I want to pour drink, I want to junk out. Once you cross the 35 barrier, you're like, थोड़ा गरम मसाला नहीं चलता है, थोड़ा ये नहीं चलता है, थोड़ा चने का आटा नहीं चलता. Once it starts to hit you, it starts to hit you in some form. That is when you get compliance and adherence. Till that time, you don't get compliance and adherence, right? And secondly, believe it or not, there is something, eating behavior is food related. I mean, it's genetics related, right? So that's where ozempic comes into picture and does a brilliant job, because it disassociates your hunger, your feeling of fullness. Well, like gene का function it enhances. So the basic idea is there are people who, like I, in my younger days, could eat a meal after a meal. So I had a very poor satiety response. Some people are very emotionally attached to food. If they're upset, something goes wrong, they need food, right? Some people have very unhealthy snacking tendencies. Yeah. The higher is a brilliant use case. The higher is with me, is my school friend from kindergarten. We got together the GeneBox. So higher used to be 5'5" and 115 kgs. Okay. And I introduced DNA test. Look, I was super notorious in school, so people don't usually, take everything I say, they'll be cautious about it. And I've done crazy things with Aya, right? So I've promised him gifts, he was given him photos, and I said conditions were very different here, redefined, etc. So we did, long story short, we did his DNA test, and it turned out he had some issues, food intolerances, and he was genetically superior athlete, an endurance athlete. And imagine I tell somebody who's 5'5", 115 kgs, struggles to 100 meters, from home to office is 700 meters for me. You should take an auto in town. Okay, to my house. And that's how bad it used to be, correct? And tell him he's a genetic athlete. So there was no belief. He's like, you're lying to me, straight through. That 2 months he didn't speak to me, but he thought it was a really cheap shot on my behalf, and I did that joke with him. Then I sat him down again. I said, dude, jokes apart. You're genuinely a genetic athlete. Trust me. The brother now runs a half marathon in less than 90 minutes. Wow. Last year he ran 5,500 kilometers. So on an average, if you see his daily step count today, it's somewhere around the region of 18 to 30,000 depending on how much he's ran that day. I was just doing some math. 5,500 kilometers, the rest take around figure of 5,400 for ease of calculation. Let's assume that he only ran 300 out of the 365 days. That's still a mileage of 18 kilometers a day. His VO2 max is 65. Lance Armstrong's was 49. VO2 max is a capability at which it's like gaadi mileage kitna degi at top output. That is the human form of it, right? You know how much mileage will you get from the oxygen that you inhale, right? So yeah, I mean, today you look at him, people don't recognize him at times, and how much he weighs now. 62, 63, and now he's putting on some muscle. He's gaining so fast.
He found his destiny and purpose through his own genes and genetic.
So I think stories like these are so powerful and inspiring to, I mean, we've got tons of guys like this, right? So we had a kid where his DNA was sequenced and then we told his mother he has a weaker Achilles tendon. So please be careful with him, and he also got a knee issue. The ACL genetically is weak. And she's like, okay. Obviously, 16-year-olds are not going to follow instructions. They end up with an ACL and a sprained Achilles. And then his mother just went berserk. She's like, this company is super awesome, etc. And ended up getting like 50, 60 customers. These are early days of GeneBox. But you have genetic testing in sport, right? So in the NFL, there is a gene called 𝗵𝗿𝗀𝗃, there's a collagen gene. So if you don't have a positive variant for it, they don't give you a contract because you want to break down, because it's contact sport. So you spend millions trying to train an athlete, but he's not going to last in the field.
Yeah.
No point. Now FIFA has started screening for some very basic markers for cardiac risk. You've seen footballers just collapse on the field, and most of them are linked to particular genetic variants that are related to certain cardiac arrests or etc. And those are the ones they want to screen for.
No, absolutely. You see so many healthy, fit people, all of a sudden you find they collapse.
Now, healthy is a very visual term in our our way of thinking, but and sometimes it's just bounded by genetics. You may be healthy, you may be whatever, but that's unfortunately how it is.
Right. So I have a question on your pan-India ambition. Right. So you want to make genomics available and affordable, not just in urban centers, but take this concept to pretty much every place in India. How do you see that unfolding? What are the challenges, and what sort of models of partnerships do you need to get that done?
So just a little brag, we almost crossed 15 countries now. So we just not pan-India, we preserve to global. 15 countries we're already delivering, we're speaking to a lot of other players in other countries, the US, the West, the Europe, etc. It's a very proud thing that an Indian company is selling robots in the UK, in the US, etc. So that's a little bit of flex that we like to have, saying that if the West is buying from us, then what's your problem, right? So, but having said that, I think India, in a country like India, I think genetic testing should be free, because surely, as Deepak earlier pointed out, that preventative is the way forward. Now, today India must be doing less than 100,000 tests a year. Even if you take India's top 3% population-wise, we are somewhere in the 150 to 200 million range that can afford a genetic test. The rest can't. And if we don't prescribe to this philosophy now, then essentially you are repeating the same mistakes that have been done for the last few decades on better food, better lifestyle, better accessibility to health. Now, if I know at birth or at an early stage that this particular individual is going to be susceptible to etc., 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 then having a better life map for them is easier, right? And I personally feel partnerships where it's pan-India. Obviously, right now we're private, we sell and we charge a certain amount of money for it, etc. Wherein we today only sell B2B, so we are there through nutritionists, we are there through hospital chains, we are there through other genetic testing companies which are consumer facing. We are trying to work with companies who are into preventative healthcare, preventative supplements, etc., to kind of help their customers decide which help customers decide which supplements are going to be better for them in the longer run, etc. The most common way of now marketing a supplement is, hey, this is a super ingredient, it's going to save you. Is it useful for you or not? I mean, take olive oil for example, right? I gain weight with olive oil. I can eat a bit bhajia, I'll be okay one day, but if I eat olive oil based salads or a little bit more pasta with extra olive oil, it affects my body differently. I can't tolerate monounsaturated fatty acids very well, so something we call as MOFA. So my body doesn't tolerate that, it doesn't like it, from olive oil, for example. So, and this is what I know, this is affirmed in my genetics as well, so confirmed in my genetics. But this is where I think overall it has to come from, the educated sector. If you look at stem cell banking, we used to help other companies. I mean, my stem cell day, we used to help other companies with their banking because we had stem cell banks. So the company is using our infrastructure to do that. And if you done the consumer mapping back then, you would have created a list of consumers who will never buy never buy a stem cell package or store for their children, etc. Today they are. I randomly get calls from people up to I had a baby boy, I've done it with this company, what is your point on this, etc. I've done the genetic test, etc. And this is how it works, right? I have done the stem cell packing, and that person was never a customer for us earlier. Today he is. So I think once it becomes widely adopted and people speak about it, there's a lot of celebrities with that. They don't speak about it because they think health and genetics is private. I think till we don't see a lot of hero stories out there, people are about to say, hey, this is dear. No, I think awareness and evangelization is key. But like I told you, I'm going to get in that for sure for myself. Right? So, but then a few startup founders, and I told them that, boss, you have a good platform, you're selling a wearable device. Genetics क्या होता है यार, ये तो consumer behavior change नहीं होना है इसमें. And I was like, if you guys speak like this, what's going to happen?
So look at number of people that go to the gym and just keep pumping in all the way. I mean, somewhere it's not about. I think it's also people have to see the value. Maybe it's a lot through evangelization.
Failures penetration is also very less in India, right? Or less than 1%.
Yeah, but I'm seeing on both sides. One is those, like you said, other side of 30s or 40s. But also if you are younger and fitter and when you are taking a lot of protein shakes and all other stuff, I think it's time one is to also realize whether too much of that protein is around the superfood, but what's inside you that counts, right?
See, too much protein, everything of too much is bad is what I feel, right? I think too much happiness is also bad for your brain, right? You just can't tolerate it. You want peace at the end of the day, right? Once you get to a point. But I think the way forward is people need to realize that, hey, if you want to live longer, live healthier, it's not going to happen by eating at restaurants. It's not going to happen by trying to eat just organic food, because what's truly organic in there, you never really know. So it's better to have a strategy around it. But at the same time, it's if you're born with bad genetics, you better know it today than living in oblivion, right? This is what I feel. And like Tyre's story, right? And if he hadn't done the tests, he wouldn't have realized he's a genetically superior athlete. And today is a flex, We'd gone with school friends to 𝗵𝗲𝗀𝗃, and he's like, gets up at 5 in the morning, runs 10 kilometers, comes back, plays paddle, and then he's in the pool, and I was like, pure show off, right? I mean,
𝗵𝗵𝗃. Awesome. That was a fascinating deep dive into the world of genomics and in what's unfolding in India and everywhere else. And the one takeaway for me is health and well-being is not necessarily just around doctors or hospitals. It's actually with data, and the data is coded inside us. And awareness, I think evangelization, I think Deepak spoke about it. That's the need of the hour. And I'm connecting it back to the big data problem that you spoke about and the AI story. So today we have these enablers, and I'm waiting to see what's going to unfold in the near future.
We're very excited about what's coming next, right? And I was telling you earlier, we've seen some really promising data that's coming up of personalization of food, supplements, etc., exercise routines. So it's exciting times, yeah.
Oh, awesome. And I think if it makes you think that if a simple pharmacogenetic test could decide whether the drug you are prescribed with will heal or harm you, shouldn't this be standard for everybody? I mean, I think this is a kind of blur we love to create out here because there are big complex ideas. I think breaking it down to simple bite size, what it means to build it, how it's changing the lives of people around, creating awareness about path-breaking ideas that needs the kind of attention and awareness. And I think through this conversation, you have helped us break it down. Really thank a lot for coming and spending this time with us, Pranav, because I think genomics has to be understood. Just like a DNA has made us what we are, we need to understand what makes us and how it helps us to live a better life. And I think very exciting session from both of us. Thanks for having me.
Absolutely. Thanks for clearing the blur on genomics, data, and AI.
Cheers.
And we'll be back next week with another guest, another conversation, and another blur to clear. Until then, stay curious.